So ideally, and I'm going to go over factoring the way I factor. So when A is not 1, I do our big star. And this is A times B. I'm sorry, A times C. Look at me making stuff up. A times C. B goes down here. A times X. A times X. And when I say A and C and B and all those fun things, I'm talking about AX squared plus BX plus C. And that's very important for the quadratic formula as well, to make sure you know the AX squared plus BX plus C. So you know what A is, B is, and what your constant is in that C. So A times C is going to be 3 times a negative 5. So it's a negative 15. Our B value is going to be a negative 2. Our A value is going to be a 3. So we're going to put 3x and 3x. So you're looking at the things that multiply together to give you 15 that will add or subtract to give you 2. So multiply to 15, add or subtract to give you 2. And obviously negative 15, negative 2. I pick up the negative conversation after I find the pair that's going to get me closest. So we have 1 and 15, 3 and 5, and that's it. My B value is negative. So since the B value is negative, your largest of the pair that you're going to choose is going to have to be negative. So I have a negative 5, positive 3, and negative times a positive does give you that negative. If I owed you $5 and then I paid you $3, then I still owe you 2. So that's great. So that pair works. I'm going to look at this, what I call not fraction. It's not a fraction. And see if I can reduce it. I cannot. 3 and 5 are prime. So 3x minus 5 is our first factor. Then I'm going to look at this guy. It's a not fraction. We're just pretending. It's kind of getting around the dog, trying to figure him out. So 1x and 1, because 3 will go into 3 one time. And then that falls out as x plus 1. Now, as we talked about before, you can multiply them back together. You can go type your given equation first and then your answered factors into Desmos and make sure that it matches. Just to make sure you did that part right, especially before you go to the next part. So to solve, when you're solving, you are solving for the roots, the zeros, solutions, x-intercepts. I think there's one more, but I can't think what it is right now. Roots, zeros, solutions, x-intercepts, answers. Sometimes is what it says. What is the answer to the quadratic formula? That's this equals to 0 part and now solve. So we're going to solve for x. We're going to add 5 to both sides because that's the inverse of that minus 5. So 3x equals 5. 3x is 3 times x, so the inverse will be division. So that's going to give me x equals 5 over 3. And for conversation's sake, we're just going to leave it 5 over 3. But you can turn it into a decimal. That's going to be depending on the teacher, the worksheet, the program you're using, which one is necessary. I'm okay with the fraction right now. So we're going to subtract 1 from both sides to get x by itself because that's the inverse of addition. So negative 1. So our solutions should be negative 1 and 5 over 3. Now, you can get, when it says solve, the only reason you have to do it this way is if it asks for the factors. If it doesn't ask for the factors and it just says solve, you can go type in 3x squared minus 2x minus 5 into Desmos and go see where it crosses the x-axis. Like literally on the graph, visually where it crosses the x-axis should be at negative 1 and 5 over 3. And or you can use quadratic formula. And I set myself up. Yep, there we go. So quadratic formula using the same problem. So 3x squared minus 2x minus 5. We should still get that negative 1 and 5 over 3 when we're done. So in this case, our A value is 3. Our B value is a negative 2. And our C value is a negative 5. If you do not have quadratic formula memorized, as I mentioned before, there's an amazingly obnoxious song that I will post. And you can definitely listen to it and it will stick. Negative b plus or minus square root b squared minus 4ac all over 2a. And there's a couple of different ones, but it's to the tune of row, row, row your boat. And it's real obnoxious and you will magically memorize this formula. So it's a minus squared minus 4a and c all over 2 times our a value. So our a value is 3. Our b value is a negative 2. And then your c value is at negative 5. You can type this in Desmos and get an answer as well. I can't switch between screens the way I'm recording at the moment. So I over explain when I do this guy because I will make an error for sure. So negative 2 squared is going to be 4. Negative 4 times 3 is 12 times 15. Times a negative 5 should give us a positive 60 all over 6. So that's 2 plus or minus the square root of 64 all over 6. The square root of 64 is asking what number times itself will give me 64. So if it was a cube root, it would be what number times itself 3 times would give me 64 or whatever number. But in this case, when there's no number in the front, it's an assumed square root. And the square root of 64 is 8 times 8 equals 64. So 8 squared. So that means we're going to do 2 plus 8 divided by 6, and then 2 minus 8 divided by 6. And that should be our answers. So we have 10 over 6, which will reduce to 5 over 3. Always reduce. We are now in high enough math that you will always, always, always reduce. 10 over 6 will absolutely not get you credit. Okay, then 2 minus 8 means a negative 6 over 6, which is a negative 1. So again, our solution set, as before, is negative 1 and 5 over 3. So you can use quadratic formula. You can factor in then set equals to 0 to solve. But the idea is that you're finding where it crosses the x-axis. The only times that factoring will not work is if they are imaginary, and that's when you could use your quadratic formula. And you would know that by looking at the graph in Desmos and seeing that it does not touch the x-axis. This graph does touch in 2 places because there are 2 solutions. And that's where the discriminant came in. So you could do the discriminant and find out, and the discriminant, remember, is just this portion of the quadratic formula to let you know if it's going to have 1 solution, 2 solutions, or no solution. And no solution would be that imaginary. And again, they do exist. So no solution is a terrible habit in Math 1 that we pick up. But for now, it is what it is. I'm going to factor one more just for practice. And then we will be open for questions. So again, we're going to use what I call big star. So a times c, b on the bottom, a times x, and then our factors are going to go down here. Our a value is 5, our b value is 19, and our c value is 12. Sometimes I really hold myself to making that little chart over there so I don't accidentally push in the wrong things into the wrong places, just like careless errors, because we definitely know what we're doing at this point. So 5 times 12 is going to be 60. Our b value we said was 19. That goes to the bottom. And then a times x, which is 5x. And as I'm getting really excited, you do want to always check for GCF first. Because I have 12 and a 5, I know there's not a GCF other than 1. And 1 doesn't really help us because 1 times anything is the same number. So it's not really actually even going to make any difference. We still are going to have a 5, a 19, and a 12. But you do want to check for GCF first. So we're looking for things to multiply together to give us 60 that will add or subtract to give me 19. So I have 1 and 60, 2 and 30, 3 and 20. Uh-oh, got an error. 15 and 4. And then you're going to be back at 20. So that would give me 61 or 59, so that's not it. 32 or 28, not it. 23 or 17, which is not it. And that's me just adding or subtracting the pairs in my head real quick. And then 4 and 15 will give me 19. They're both positive. So 15 and 4. B is positive, so 15 is definitely going to be positive, but I need them both to come together to give me that positive 19, so they're both going to remain positive. We're going to look at our not fraction in the front, 5 over 15, and ask ourselves, can it be reduced? Can it get any neater and nicer? 5 and 15 both can be divided by 5. So that's 1x. And remember, it's still a fraction because it's not actually a fraction. We're still going to write it as a fraction because these guys fall out and ends up being x plus 3 for our first factor. 5 over 4, looking at the not fraction. 5 and 4, 5 is prime, not even, all those fun things, so it can't be reduced. So we're just going to write it as is. So 5x plus 4. These are the factors. So if it said factor it, you're done. If it says solve it or ask what the solutions are, what are the x-intercepts, what are the zeros, then you are not done. When you're solving for zeros, you are going to set both of these factors equal to 0 and then solve for x. And as I've said it before, can't say it enough, also because we are now in Math 2, we could plug this in Desmos and go see where it crosses the x-axis on the graph to make sure we do our math right as well. So 5x, we're going to subtract 4 because that's the opposite of addition. 5x is actually 5 times x. So we know the inverse of multiplication is going to be division. So we're going to divide both sides by 5. Make sure you're keeping up with that negative sign because a negative 4 over 5 is a totally different number than a positive. So x equals negative 4 over 5. So our solutions are going to be negative 3 and negative 4 over 5. And we just write them as a list.